In this workflow, we'll establish the ducting that'll run along the sides of our fuselage. Notice the inlet location and outlet location included in our custom block inputs. These locations can have different X, Y, and Z coordinates, signifying that the ducting won't always be coplanar. To simplify our modeling, however, we'll approach modeling in the 3D space in a couple of phases. For simplicity, let's start with working in the XY plane. We can begin by setting a path for a single side of our ducting using the Spline by tangents block. Switching to a top view, let's see how we model this. We can begin by establishing our start point and our end point. We do this by grabbing the X and Y coordinates from our inlet and outlet locations, and since we're just working in the XY plane for now, we can set our Z's to 0. We'll then set our start and end tangents to face one another in the positive and negative X directions. Expanding our spline by tangents block, we see that this spline is generated by 4 points: the start point, the end point, and 2 points in between. To generate those intermediate points, we just translate our start and our end points by our start tension and our tangent, and the end tension and our tangent. That creates these 2 points, and we finished creating our points list in that block. Next, we'll create a vector list for our tangents, using our start and end tangents for positions 0 and 3, and our path start tension and path end tension for positions 1 and 2. That generates the spline that we see here, which has a field that looks something like this. Changing our color map to implicit and adding our ISO lines, we see an SDF that radiates from this spline. Later in our workflow, we'll want to work with a field that has a positive and a negative side. So we can use the profile from curves to generate an SDF of this open profile. Now, on one side of our spline, we're all positive, and on the other, we're all negative.